Here are the top 5 things I learned about robotics and PCB design from my 2024 projects. Number 1. Don't use linear regulators when the current requirement or voltage drop is too high. The efficiency of these things is literally the input voltage divided by the output voltage. So just because an LDO says you can shove in 16 volts and get 3.3 volts out at 1 amp, it doesn't mean you should. You should just get a buck converter to do that instead. Aim to use LDOs for low current, high voltage drop, or high current and extremely low voltage drop. Number 2. In high power motor control systems, use components which are rated for double or even triple the maximum voltage that will be applied to them. Because regenerative braking, whether intentional or not, can generate some serious voltage spikes. TVS diodes on the supply voltage can help clamp these spikes to an extent, but the most important thing to remember here is component derating. Number 3. When you have a large amount of low ESR capacitance in a system, the inrush current normally causes a spark within the battery connector, and that's not good. This can be fixed by a resistor in series with a capacitor, a soft start circuit, or an anti-spark digital power switch. Number 4. The highest of the many continuous drain current ratings of a MOSFET is not what it can handle in any practical application. I mean, come on, this tiny little thing probably couldn't even dissipate 25 watts with a heatsink the size of my head and liquid cooling. So no, it isn't a 50 amp MOSFET. Instead, look for this sort of rating, which is normally just about the lowest one, or if you can't find that, divide that super high continuous rating by 10 to get a conservative estimate of about 5 amps when mounted on a PCB with an average amount of copper to dissipate heat. If you need more current, choose a different MOSFET or spread more of the heat away. Number 5. Most LiPos have a C rating that is utter bullcrap, especially since no one conducts actually scientific tests on them. I mean, come on, 1200 amps for a whole 25 seconds? The real question here is what's going to catch on fire first? The 10C rated wires or the 15C rated battery? Oh wait, I know, both! For cells marketed as high power, you can realistically expect 15 to 45C from your pouch cells and 7 to 12C from your cylindrical cells from fully charged all the way down to fully discharged. Anyways, here's the full 2024 recap video and subscribe because I'm trying to hit 50K this year. Thanks.